Imagine you've just walked into a factory. Raw materials arrive on one side, travel through machines, and leave as completely different products on the other. Every machine has one very specific job. One machine paints, another cuts, another packages. Now imagine your IGCSE exam asks you about functions. Instead of memorizing confusing rules, just picture this factory. Once you understand how the machines work, functions, composite functions, and inverse functions all become incredibly simple. Let's step inside. A function is just like one machine in our factory. You feed something into the machine, it performs one specific job, and something comes out the other side. The thing going into the machine is called the input, which we usually write as x, and the thing coming out is called the output, which we write as f of x. The important rule is that every input can only produce one output. If the same product went into the same machine twice, you'd expect exactly the same finished product to come out both times. There are no surprises. Take the function f of x equals x plus 5. Imagine this machine has one simple instruction written on it: add 5. Whatever number enters the machine adds 5 before sending it back out. Put in 3, and 7 comes out. Put in 10, and 15 comes out. The machine always follows the same rule. Now let's learn two important words you'll see in exam questions: domain and range. The domain is simply every input the machine is allowed to accept. Imagine our factory has a machine designed only to process wooden blocks. If someone tries to feed a football or a bucket of water into it, the machine rejects it because those aren't valid inputs. The list of acceptable inputs is called the domain. The range is every possible output the machine can produce after it's finished processing the accepted inputs. In other words, it's everything that can come out of the machine after the transformation has happened. Next, let's make the factory a little more interesting. Instead of having just one machine, imagine the conveyor belt carries the product through two different machines, one after another. This is exactly what a composite function is. Suppose the first machine is called f, and the second machine is called g. When you see g of f of x, don't panic. It simply means the product enters machine f first. Whatever comes out of that machine immediately becomes the input for machine g. You always work from the inside out. The output from the first machine becomes the input to the second machine. Think of it like a production line. One machine cuts the material, then the next machine paints it. You would never paint something before it's been cut if the factory wasn't designed that way. That's why g of f of x is completely different from f of g of x. If you swap the order of the machines, you change the entire production process, and you'll usually end up with a completely different final product. The order matters. Finally, let's look at one of the most useful ideas in this topic: the inverse function. Imagine our factory installs a special reverse machine. If the original machine packs a product into a box, the reverse machine unpacks it. If the original machine adds 5 to every number, the reverse machine subtracts 5 to return the number back to where it started. The inverse function is simply the machine that undoes everything the original machine did. That's why we call it the undo function. Mathematically, you'll recognize it as f to the power of -1 of x. To find it, start by writing the function as y equals the function, then swap x and y because we're reversing the entire process. Finally, rearrange the equation so that y is on its own. The result is your inverse function. Once you start thinking of functions as functions on a factory production line, every part of this topic becomes much easier to understand. A function transforms an input. The domain tells you what the machine accepts. The range tells you what it can produce. Composite functions pass products through multiple machines in sequence, and inverse functions simply reverse the entire process. If this explanation made functions finally click, you'll love learning the rest of IGCSE Maths this way. Download the practice book using the links in the description to practice these questions with structured exam-style exercises, revision notes, flashcards, and progress tracking. And if you found this video helpful, subscribe for more quick, visual IGCSE Maths revision designed to make difficult topics feel simple.